Hello, so today we're going to talk about how to solve a compound inequality. So last time we talked about how to solve linear inequalities. Now a compound inequality is an inequality that has two inequality symbols. Solving these is the exact same process before, but now we don't just simply add them to like the left and right hand sides of the inequality, or subtract or divide or multiply, whatever. Now we have to do it to left, center, and right to every single piece. The key to remember is that if you start with two inequality signs, you have to end with two. You can't like somehow move one of the numbers with the inequality sign back to the middle and get rid of a sign. It doesn't work that way. So this is what a compound inequality looks like. Again, we have our two inequality signs right here. So to solve this, if we pretty much just ignored for a second this expression right here, just kind of ignore it, we want to solve this, we'd have to add 2 to both sides. And if I were to do the same thing over here, and if I want to ignore this one just for a second, to solve this we would have to add 2 to that side. Well, if I want to solve it in the compound form, I still need to add 2. I add it to the left side, the middle to cancel, and to the right. 8 plus 2 is 10, so we have 10 less than 5x less than 15. And now to solve this one, again, if I were to, I'm not going to constantly erase stuff, if I were to cross out this part right here, I need to solve for x by dividing by 5. So we divide by 5 to the center to cancel, and then the left and the right to make it even. 10 divided by 5 is 2, less than x, less than 3. That is our compound inequality answer. Very straightforward. We started with 2 inequality signs, we need to end with 2. And beyond that, we solve the exact same we solved any of the other inequalities, which also means, had this been a negative 5, when I divide by negative, the inequality signs would have to flip. So keep that in mind. So I have negative 7 less than or equal to 4x plus 1, less than 21. So I need to move this positive 1 by subtracting to cancel. Subtract it from the left and the right hand pieces. Negative 7 minus 1 is negative 8. Less than or equal to 4x. Less than 21 minus 1 is 20. And then to solve this, we have to divide everything by 4 to cancel there. And then to make it even, divide by 4 on the left and the right. Negative 8 divided by 4 is negative 2. Less than or equal to x, less than 5. So there's that inequality answer. Again, the only difference is now we have 2 inequality signs. Beyond that, it's still the exact same process. We still need to move things around to isolate the x. We now just do it to 3 pieces instead of just simply the usual 2. So here, we need to move the positive 9 by subtracting. Negative 14 minus 9 is a negative 23, less than negative 7x, less than or equal to 20 minus 9 is 11. So we divide everything by negative 7. So if I leave them as fractions, negative 23 over negative 7 is a positive 23 over 7. Because I divide by negative, this sign would have to flip. X divided by negative, this sign will have to flip. Greater than or equal to negative 11 over 7. Or if I want to write them as our decimals, it'd be 3.286 less than x, less than or equal to negative 1.571. So again, fractions or decimals don't really care. Both are correct, as long as your fractions are reduced. And then lastly, this one, again, the process is still the same. I need to solve. So one thing I always like to do is I like to give our fractions immediately, that we're not dealing with fractions throughout the problem. So multiply everything by the denominator of 3. So negative 20 times 3 is negative 60, less than or equal to. Nothing changes up top, so it's negative 2x. 4 times 3 is 12. And then negative 2 times 3 is negative 6. So now we subtract 12 from everything. Negative 60 minus 12 is negative 72. Less than or equal to negative 2x. Less than negative 6 minus 12 is negative 18. Don't forget they have the same signs, so we just add the numbers and keep that sign. And now we divide everything by a negative 2. Negative 72 divided by negative 2 is a positive 36. Divided by negative, so this inequality flips. Becomes greater than or equal to. X greater than. Negative 18 divided by negative 2 is a positive 9. So that's all you gotta do to solve compound inequalities. It's a very straightforward process. You're just moving them around the way you would for a normal equation. These generally don't get as complex as normal linear inequalities. It's kind of tough to have x's like everywhere, for example, the left and the right-hand sides. You really would need to have two different inequalities to solve that. But if it's just this straightforward like this, you just move everything out of the middle until x is by itself. So next time we're going to talk about how to solve absolute value inequalities. So I'll just see you next time.